Synchronous counters are so called because the clock input of all the individual flip-flops within the counter are all clocked together at the same time by the same clock signal. The external clock pulses to be counted, are fed directly to each of the JK flip-flops in the counter chain, and that both the J and K inputs are all tied together in toggle mode, but only in the first flip-flop FFA, LSB, are they connected high, logic 1 allowing the flip-flop to toggle on every clock pulse. Then the synchronous counter follows a predetermined sequence of states in response to the common clock signal, advancing one state for each pulse. The J and K inputs of flip-flop FFB are connected directly to the output QA of flip-flop FFA, but the J and K inputs of flip-flops FFC and FFD are driven from separate AND gates, which are also supplied with signals from the input and output of the previous stage. These additional AND gates generate the required logic for the JK inputs of the next stage. If we enable each JK flip-flop to toggle based on whether or not all preceding flip-flop outputs, Q, are high, we can obtain the same counting sequence as with the asynchronous circuit but without the ripple effect, since each flip-flop in this circuit will be clocked at exactly the same time. Then, as there is no inherent propagation delay in synchronous counters, because all the counter stages are triggered in parallel at the same time, the maximum operating frequency of this type of frequency counter is much higher than that for a similar asynchronous counter circuit. Because this 4-bit synchronous counter counts sequentially on every clock pulse, the resulting outputs count upwards from 0, 0, 0, 0, 0, to 15, 1111. Therefore, this type of counter is also known as a 4-bit synchronous up counter. However, we can easily construct a 4-bit synchronous down counter by connecting the AND gates to the Q output of the flip-flops as shown to produce a waveform timing diagram the reverse of the above. Here the counter starts with all of its outputs high, 1111, and it counts down on the application of each clock pulse to 0, 0, 0, 0, 0, before repeating again. Circuit diagram. you for watching. Please like, share and subscribe the channel.